You'll note that the fuselage shape is a little bit different. It is that way to preserve what I thought was a desirable 3-to-1 taper ratio aft of the pilot. It tapers a bit more slowly than the fairly rapid restricting taper of the prototype. This also suggests that it might be better not to have the fuselage taper quite so quickly at the same time that the wing is tapering. That's just something I think, but we'll see how that goes. This is kind of you'll notice here also that there is a fillet. This is made out of carbon too. This all the parts are that are exposed to the weather, and you can curve them, and instead of just straight away, you can make them nice and rounded. Oops, let me get down here so you can see. But you'll see that the fillet has a nice round shape to it. The main body is also somewhat shrunken frontal profile. I'll show you that from the front. The body is rounded, whereas with plywood you wouldn't be able to make a compound curve like this. I made the aileron connection opening much smaller, and also you will note that the top part of the this is interesting. This turtle deck here on the prototype is just a piece of plywood on the top, but mine is an actual section that was built out of carbon and fiber, so that it matches the profile of the trailing edge exactly. And it follows a curve back into the fuselage, nice streamlined curve. And what this does is it allows me to have a much better connection, a much smoother airflow for the spoiler over when it's set down. And if you make, you'll notice that there's a cutout right here. That is because the spoiler rear support beam, you'll see, is on the underside of my spoiler instead of on the top side. By putting it on the underside, you don't turbulate the flow nearly as much. And this is allowed. This beam is accommodated by this cutout on the aileron gap cover. Okay, so we'll see that. You'll see that. Let me just go back and close the spoiler, and you'll see how smooth the connection is. Perhaps before I do that, it's important to note one more thing. When the spoiler is in either of the open positions, the parachute will fire and exit out underneath the spoiler. When it is completely closed, as it might well be in normal flight when you have a problem and need your parachute, the spoiler is designed with a pocket in the middle. This is fabric here. So by using a graphite, extra graphite in the main body of the spoiler, you can have the rigidity necessary to make this part open, and you can cover the whole thing with fabric. Now the parachute will blow through the fabric when the spoiler is closed. Okay, I've closed the spoiler, and you can see how nice and smooth the transition is between the main part of the wing and the spoiler. It's important that you build the spoiler after you have the wings finished, so you can have that curve occur. You don't want any big gaps in there if you can help it. And you'll notice that the spoiler follows the trailing edge and sits nicely on the turtle deck, which also has a little bit of a rise to it to accept the trailing edge, the airflow off of the spoiler. Okay. Again, I mentioned that the change in profile of the front, the fuselage, and you'll notice also that the fin leading edge is made out of graphite as well. And because it's graphite, you can mold it, and you don't have that straight transition right into the main tail boom like that. You can have a nice, relatively, well, at least more drag-free form for the wind to catch here. Now this might be helpful to show you the connections here. Let me just go down and show you how these look. Okay, can't get too close. I guess I'll lose focus here. But anyway, those are the connections. They are. I made them. The rear connections for the stabilizer have an airfoil shape to them. Okay, so wingtip again. The aft gap cover here has got a little bit of a curve to it to meet the neck surface, so that minimize turbulence, airflow turbulence. We'll go and take a look at the. Now you should note, this is interesting because the only part of the glider that is not made with carbon was the one part that I made first. And we're going to take a look at this, and I'll show you what I mean about changes in humidity. Okay, now if you look at this section right here, the leading edge of the stabilizer is plywood. And if you look at it, you'll see wavers a little bit in between the ribs. It's not significant, but there is some. And if you were to look right straight down the leading edge, you'll see places, you see a little bit of there because of the light changing. But it changes. No matter what you do with the plywood, unfortunately using very thin 1/32 inch plywood, the weather gets to it. Okay, this is the edges. I put balsa covered with graphite on the tips to have it nice and round. Has a graphite trailing edge. Look at the tail wheel is a little bit different as well. Okay, the tail wheel is up and out of the drag. I put it up high like this so that it wouldn't bust off if I hit an obstruction from the back. And it seems to ride over very easily, and it, because it's behind the mainspring there, however insignificant, it does provide a little bit less draggy profile. Okay, look at that. You'll notice the real nice shine on the surface of the paint. That is called a Superflight paint. And it's fairly expensive. It's a two-part paint, and it's environmentally very difficult to deal with. You have to have a supplied air surface, air supply, and it's best to do it in a paint shop where they can handle that type of thing. I hired a paint shop to help me paint it, and the fellow was very good, and we haggled quite a bit about how much paint to put on. Probably ended up with 2 or 3 pounds more paint than I should, but it did provide a very nice surface, so I'm grateful for him for that. You can see the sheen on the surface of the wing. It's permanently, doesn't ever need to be waxed. Let's go take a look a bit more at the front profile. Okay, I want to show you the frontal profile of the glider. You'll see that it's a fair amount more rounded than the prototype, and it's narrower at the base, and it maintains perhaps a little bit more of an aerodynamic shape because, again, it's not plywood. You can have a compound bend here because I'm not using plywood, it's molded graphite. And with the fuselage has got a Kevlar, graphite, and fiberglass composite, one layer of each. The Kevlar keeps, in case I land in the woods, keeps the sticks from coming through, and also the graphite shards if it breaks. So you want to make sure you put some Kevlar on your fuselage if you're going to use the graphite. Okay, a little bit more front profile here, and then we'll go down and take a look at the skid and the nose skid and the release. Mine's a little narrower, but because it's composite, it can maintain its strength in a little bit narrower section. And the release is right there. It's very similar. It is the release that's in the plans. And the side view is right there. I redesigned the bows a little bit so that the airflow is straight from the nose all the way up to the leading edge. And I'm going to put the canopy on now so you can have a look and see how that works. Okay, now I was mentioning that the canopy, the line of the canopy, upper line of the canopy is straight all the way from the nose up to the leading edge there. And we'll get a chance to take a look at the canopy here in just a second. Okay, you'll notice that the line of the canopy is straight. Maintains a constant airflow line right from the nose all the way up to the leading edge. You'll also note that the canopy is a full canopy and required some compound bending of a material that's not supposed to do that, but it was accomplished by changing the bows a little bit. And you'll see first off that the canopy, where it connects to the fuselage, again emphasizes that reattachment rule. It comes in, and then it's forced to attach to a secondary surface that's a little bit outside the airflow, all the way down here, so you have reattached flow. The compound bend is accomplished by making this bend right here, right near the leading edge, much sharper, so you effectually have almost a straight surface along this one here, which allows the Lexan to go from bending in this manner to bending in this manner. And it connects, as that one has, to the other side there to hold the side pieces of the canopy in. The canopy is as per plans, is captured by the fillet on the side here. It goes back and is captured like that. So this is a full canopy for the Carbon Dragon, made out of a single flat wrap piece of Lexan. Turn a flat wrap into a compound bend. The front canopy requires a fair amount of pop riveting to hold it in place. At least it did for me. It's stuff that just does not want to assume the position that you're asking it to do, especially if you have a compound bow, as mine is. If you want to have a rounded fuselage, you have to deal with flat wrap material, and sometimes you have to force it a little bit. So you can see how the instrument bracket holds the pitot and static in the front. It also holds the GPS with the antenna right near the surface, and that is a ball graphics comp Vario with the GPS connected to it. From this view through the canopy, you can see the release mechanism, the flap control lever, the brake on the floor there right next to the sling. There's the brake handle, static and pitot mount up here with the lines that go to the Vario. On this side you have the bungee that holds the canopy down, and you have the side stick right there. Okay, we'll look through the canopy. I guess we're not going to be able to look through it, the reflections too. We're back here in the back of the fuselage now. I want to show you if you use graphite or material that doesn't expand and contract too much with the humidity and the temperature, you can maintain fairly close tolerances. Now, the ailerons here, the aileron gap is airflow restricted by a little piece of material I got from the people that make storm windows. It's kind of a fuzzy little thing that's sticky on one side and fuzzy on the other, but you can shave that down with an electric shaver to get it so it just restricts the movement of the aileron a little bit. It helps control any type of flutter oscillation, but it also maintains absolute airflow, control of the airflow. I can't show you right now, but the gap is sealed between the aileron and the main part of the wing, and it's sealed right along the hinge line on the undersurface of the wing. One more look at the wing. And out the other side here. I have made winglets for this glider, and I'll show you where they will be attached on the leading edges here. And they're right here and here to accommodate the winglets that will go right over, and there's a hollow portion in the winglet that allows the mass balance, the aileron balance to ride up and down inside of the winglet. I haven't had enough air time on the glider yet to pronounce myself capable of telling whether or not the winglets would be effective yet, so when that happens, I'll try out the winglets. This is the wheel. I made a fairing for it as well. I used a Continental wheel that I got from Wings and Wheels. It's a very lightweight wheel with a plastic balance, and I used a hollow, I believe it was a 12 millimeter axle, a hollow tube. The entire wing was covered with fabric as per the Superflight system. The main wing has one joint, fabric joint, and I chose to put it right in the most high pressure section of the wing. I don't know if you can see it or not, but it's right underneath the leading edge here. The sun will shine a little bit. You'll see a little hint of a gap there. I didn't put any tape over the top of it, but the Superflight system gives a very smooth, shiny, wet look finish to it. And they say it requires no maintenance, and it's also got UV protection with one layer primer and one layer of finish coat.
So that's my magic dragon.